Okay, so let's rerun those analyses, except this time, instead of having the three age groups as the division for age, let's replace that and put in five age groups. Okay, so this variable will be at the bottom of your variable list. Why don't you go ahead and make that substitution so it looks like this, right? And then we're going to go over to plots. Let's just double check and make sure everything is there that we want. We're going to move age group over horizontal axis and sex to separate lines. So we'll hit add and then continue. Okay, and then we come into post hoc tests. We'll move age group over there since that's the one with more than two groups. And we'll have Tukey and Bonferroni run. Click continue. We'll go over to options and let's display the means for all of these. And we'll have Bonferroni test selected down here, and then over here we have all the other display options for descriptive statistics, effect size, observed power, and so forth. So I think we're all set. We'll hit continue. Okay, and make sure that you've got all that set, and then we'll click OK, and up will come our output. Okay, so what this is going to do is produce the same output that we just had when we were running with three groups, because we now have five groups, and you can see here that the five groups are divided fairly equally in terms of age. So our ends are pretty good within each group. This is a pretty large sample. We start looking at males and females and the age group means, and real quickly we might see for males a mean of 25.79 irrespective of age. For females it's 27.42, and then the total is 26.73. So there's a little bit of a difference right there between the males and the females. And then down here, we see across these age groups higher levels of total perceived stress for the 18 to 24-year-olds. And then it looks like it goes down a little bit in the mid 20s, and then pops up a little bit in the 30s and 40s. So we'll see if there's anything going on there. Quality of variance test, 0.418, we're good. This is bigger than 0.05. And then we come down to the tests of between subject effects. We look across this first row, we say, yep, there is a significant finding in there somewhere. We don't know where, but it's telling us that it is there. So now let's look at the main effects and the interaction effect. If we go across the interaction, not significant. So the effect has to be one or two main effects. And as we look into the p-values, it looks like we've got two main effects, one for sex and then one for age group. Okay. And here are our effect sizes. These are pretty significant effects, but they're associated with small effect sizes. So you have to just go through and interpret those, but those are not particularly large. 0.03 is getting up there just a little bit more. Okay. And again, those effect sizes are relative to these specific factors. So this is the proportion of variability in total perceived stress uniquely accounted for or shared with sex. It's 0.02, about 2%, and then with age group, it's about 3%, 3.5%, and that's larger than what we would expect by chance or measurement error. Okay, so we come down to these estimated marginal means, and really the printout's going to give us a couple of things. One is here are the means for males and females, irrespective of their age. And then I'll just do a quick pairwise comparison, and that is significant at 0.004. It then runs the ANOVA, and basically this was like a t-test. It runs the ANOVA again, gives you the exact same p-value, okay, except that it's reporting it as an F ratio. So these p-values here, right here, 0.004, and here will always be identical when you have just two groups. Then we go down to age as five groups. Here are all the means for the five groups as they're broken down by age. Come down to the pairwise comparisons. We already know that there's a statistically significant effect for main effect for age. So we know we're going to find some asterisks in here, and so we find a significant difference between the 18 and 24-year-olds and the 25 and 32-year-olds, as well as the 18 and 24-year-olds and the 50 plusers. So this is interesting because, right, look at the 41 to 49, it didn't pan out. So breaking down the upper end of the age bracket did result in a better understanding of the data. It's really the 50 plus folks, the folks in my age bracket, yay hey, who are feeling less stressed. And it looks like the folks in your age bracket are feeling the most stressed. So something to be learned there. So here we go. So we keep moving on down, and we'll find that other asterisks are going to be popping up as well. Let's see, there's 25, 18. Okay, so we already saw that. I guess not. I guess it's maybe just those two, huh? So the 25 to 32-year-olds are significantly, um, it looks like, higher scores for the 18 to 24-year-olds. So the 25 to 32-year-olds are significantly less stressed than the 18 to 24-year-olds. And the 50 plusers are significantly less stressed than the 18 to 24-year-olds. That's pretty much what we're finding. Okay, there's the actual F ratio right there. If we did, let's see, we come down to the interaction effect. We already know that there's no interaction effect, so when we come down here and look at anything else, we're not going to find anything. You know, just all the post hoc tests are going to be run. It's pretty much telling us what we already knew. I don't see anything there different. Here are the homogeneous subsets. So the 25 to 32-year-olds, 50 plusers, 41 and 49, and 33 to 40s form one subset, and the 18 to 24-year-olds, 33 to 40, and 41 to 49 form the other subset. Okay, and then here's the plot out of the marginal means. So you can see that the interpretation, you just have a different kind of output, a different picture that's being painted, and all we did was break age down into 5 groups rather than 3. We've got maybe just a little bit richer picture of what's going on there. So double check and see if your data kind of panned out the way they panned out here. It panned out here. Okay. Alrighty. So I think that's the end of that. Now that you've gone through and you've run this kind of analysis twice, why don't you go in and run your Wawa analyses? I think at this point you've seen this done enough times that you should be able to do it without any problem.